Hello and welcome to our last episode in our series on random numbers generation with Numpy. You have seen how to generate or sample random numbers from a normal distribution and from a uniform distribution as well. And in this video, I'm going to show you two more ways in which you can generate random numbers within a range that you want to specify. But before that, I want to tell you about seeding. Okay, so I'm going to use a cell up here for an example and observe the values that are returned very carefully. You can see that the first value here is 0.3765 blah blah blah. If I run it, you see it changes. Anytime I run, the values are going to change. Anytime I run the cell, the values are going to change because of course these numbers are generated by pseudo-random number generators. Okay, now what seeding allows us to do is to help us to have predictable values in our random numbers arrays. And the reason this is important is, for example, as you're watching this video, there is no way I can guarantee that the random numbers you generate on your computer is going to be the same as the random numbers you are seeing in this video, because of course they are supposed to be random. But sometimes it becomes necessary for us to wish or ensure that we can both have the same entries in random numbers that we generate. It is particularly important in the practice of deep learning because in deep learning, like I said, most of the times our weights and biases are initialized randomly. And so there is no guarantee that if I perform training on the same architecture, on the same data set twice, I will have the same performance, I will have the same accuracy or whatever metric I am using to measure how well my neural network is performing. But to help you to be able to reproduce my work and have exactly the same output, what we can do is to seed the pseudo-random number generator such that when you call the random number generator function several times, you are guaranteed to have the same entries. Okay, now let me show you how to do that. It is as simple as calling np.random.seed, and then you can seed it with any value. I'm going to choose 0 here. You can read more about it by googling np.random.seed, and you go to the Numpy official documentation, and what they are saying is this method is called when random state is initialized. It can be called again to reseed. So anytime you call it, it actually reseeds it. And what it means is if you reseed, then you are no more guaranteed to have the same values for your random numbers. So I'm going to generate random numbers. I'm going to just print, let's say, mp.random rand int, and this is also one random number generation function that I wanted to talk to you about. So it basically helps you to, it lets you specify a range within which you want your random numbers to come from, but as you can see from the name, it produces random numbers that are integers only. Okay, and then we also have one called rand. So of course I'm going to use the rand here, and then I'll show you how to use the rand int later. So what this rand does is it generates random numbers between 0 and 1, and is a floating point number. So as you can see, I have run this cell several times and I'm getting the same value over and over. Let me generate 5 random numbers, and you can see that this is 0.5488, 0.715. I'll run it again, and you can see that I am getting the same result over here. Now watch something. Without the seeding, you will see that every time I run, I'll get a different output. So see, you see that without the seeding, I get different output every time I run. But if I bring the seeding in here, and of course, if you also seed it with the same value on your computer, then you are guaranteed to have similar entries like I am getting on my computer. So what this np.random.run does is it helps you to generate random numbers between the range of 0 and 1, and the random numbers are going to be floating points. Okay, so I can also specify the size here. I don't know if I have to be explicit with the size, but let me see. 5 by 5. Okay, so this one doesn't take size because there isn't much that you can control. So I think a tuple should do. Okay, tuple cannot be interpreted as an integer. Wow. So what do you expect? Okay, yeah, so this expect you to provide a size or along the dimensions that you want to generate. There is no need for you to specify the size here because, of course, like I said, there isn't much you can control here. The range is between 0 and 1 and it's going to generate floating point numbers for you. So let me show you about random int, which I spoke of, which is also similar, except that it generates random numbers that are integers only. So I'll do np.random.randint, and then I specify the low is equal to 1, the high is equal to 6, and then the size. Now I need to be explicit here because I'm trying to control the low, the high, and the size. So let's generate just 5 of them, and you can see that I have 1, 2, 2, 2, 1, and then I go again. And in case you're wondering, I seeded here, but I think in this cell I have not seeded it. If you are writing this as a Python script, you seed once and you get similar entries whenever you generate random numbers, but I don't know why it's not behaving the same way in the Jupyter Notebook cell. So basically, the randint allows you to generate random integers within the range that you specify. And of course, you can change this into a tuple to generate random numbers of multi-dimensional sizes. So thank you very much for watching, and I will see you in the next video.